Swayam Prabha. Digital India. Educated India.
Namaskar and welcome back to the video course on watershed management. In module number 6, lecture number 23, today we will discuss remote sensing and applications in watershed management. So, some of the important topics what will be covered in today's lecture include remote sensing basics, features of remote sensing process and advantages, important satellites, image processing, applications of remote sensing in surface water and groundwater, applications of remote sensing in watershed management. Some of the keywords for today's lecture include remote sensing, features, image processing, electromagnetic spectrum and satellites. So, as I already mentioned earlier, when we deal with watershed management or watershed management plans, we will be dealing with a large area just like a watershed, river basin or a catchment. So, it is a very huge area. So, where we have to get so much of data like the topographic data, land use data, land cover data, soil data. So, like that so much of data are needed to develop appropriate management plans or to develop models to study the various behavior of the system just like related to water resource management or land management or the development of various rainwater harvesting structures like that. So, since we need a huge amount of data, so if we go to field and collect data, there is limitations since we cannot get the entire data in an appropriate way which requires for a modeling or which requires to develop appropriate management plans. So, that way as we discussed earlier, the remote sensing helps in a big way for hydrologic related modeling or watershed related planning and management. So, in this context, in today's lecture we will discuss some of the basic aspects of remote sensing. Remote sensing is a big area where so much details we have to discuss, but today's lecture we will be discussing only the important perspectives which are related to watershed management and some of the basics and applications related to watershed management. So, let us now look into some basic aspects of remote sensing. So, remote sensing as already discussed earlier, remote sensing is an art and science of obtaining information about Earth's features from measurements made at a distance. So, here as the definition shows, we are not directly going and getting the data or we are not coming to contact with the various the data which we are directly collecting, but we are getting the data remotely say from a distance, say that it can be just like an aircraft flying over the area or a satellite passing over the area. So, at a remote distance say through various means we are getting the data required. So, that art and science is called a remote sensing. So, that way remote sensing is a science of making inferences about objects from measurements made at a distance without coming into physical contact with the objects under study. So, when a satellite is passing over an area, a watershed or a river basin, then it is sending certain signals or it is collecting certain data based upon its movement and various other parameters. So, that data we are processing and utilizing. So, that way there is no direct contact with the objects, but we are getting the data remotely. So, generally remote sensing means sensing of the Earth's surface from space by making use of the properties of say electromagnetic wave emitted, reflected or diffracted by the sensed objects for the purpose of improving natural resource management, land use and protection of the environment. So, this is a general definition in modern times with respect to remote sensing. So, earlier there used to be a number of ways we used to get this data remotely, either using some balloons or we use aircraft. So, nowadays we are using mainly satellites, remote sensing satellites. So, in this say we are getting the data in such a way that the electromagnetic waves emitted, reflected or diffracted by the sensed objects, we get back this data and then we process this data and then we use it in an appropriate form. So, that is the modern day remote sensing, but earlier times we used to get data through say through using flying over the by using the aircraft or by using balloons or other kinds of mechanism. So, that way remote sensing now plays a major role in most of the watershed development management plans, since we can get so much of data, since one scene gives maybe entire spectrum of the watershed which we consider, and then once we process those data we can get on our computer the details like land use, land cover, soil map or the slope map. So, all this after processing in a remote sensing package or the GIS package, we can make it an appropriate format. So, that way the modern remote sensing using satellites, we are using the electromagnetic spectrum. So, that means say you can see that the various spectrums of electromagnetic spectrum are listed here. So, here we use the bands that refers to spectral channels in the electromagnetic spectrum. So, here we can see that as per the wavelength in micrometer, there are various electromagnetic spectrum bands. So, like cosmic rays, X-rays, then gamma rays, ultraviolet, visible, near infrared, mid infrared, thermal infrared, microwave. So, then the wavelength used for television and radio. So, actually for remote sensing purpose we use this range starting from ultraviolet to sometimes to microwave. So, here I have listed various bands. So, the band means here bands refers to spectral channels in the electromagnetic spectrum. So, bands 1 to 7. So, my wavelength are given in a micrometer. So, starting from 0.5 to say 1 meter. So, the nominal spectrum location say for example, within the wavelength of 0.45 to 0.52 it is blue, and then 0.5 to 0.6 to green. So, like that. So, correspondingly the principal applications are also listed. Say for example, in this range band 1 0.45 to 0.52 we can use for coastal water mapping, soil or vegetation, then 0.5 to 0.62 which is the nominal spectral location in the green range. So, we can use for vegetation discrimination, then 0.6 to 0.69 the range of red band. So, we can use for chlorophyll absorption region, then 0.76 to 0.9 near infrared to identify or to get the application in the field of vegetation, water body, soil moisture, etc. So, like that here for various applications what kinds of bands which we are using are listed here. So, principally the bands start for remote sensing generally it is starting from this ultraviolet or this range to going up to microwave. So, that is the main region of the or the band of the electromagnetic spectrum where we generally use for remote sensing. Say for example, 1 centimeter, 1 meter or 7th band, it is the microwave. So, there we can use it for soil moisture. So, some of the advanced say remote sensing satellites use this band, and that can be used for even for soil moisture study. So, that way we use particular bands for particular applications. So, depending upon where we are using the remote sensing satellites for whether land use, land cover or soil moisture or ocean application or coastal region applications. So, like that accordingly we can choose a specific band of the electromagnetic spectrum or specific satellites are put for that particular band. So, like a Cartosat or the microwave region. So, like that. So, that way we can choose particular satellite, remote sensing satellite in particular bands for the specified applications which we are trying to do for that particular application. So, now within this background let us look into what are the important features as far as remote sensing is concerned. So, here in this slides, so the various features are listed here. So, we can see that since say here in this figure which is taken from Marwan and Kotmani 2004 modified. So, here this is the satellite or this is the aircraft which is flying over, or this is satellite moving over the surface. So, you can see that this is the way the scanning or the reception or the of the particular electromagnetic spectrum band is which is the receiver obtained. This remote sensing, that way you can see that it provides a regional view. So, if this is the watershed, so that entire region within one passage of the satellite we are obtaining. And then another important aspect is it provides repetitive looks at the same area. So, once the satellite is passing over this and again say after few days, say or 1 week or 2 weeks like that, then again the same area the satellite may be passing. So, that way we get the data again in a repetitive manner. And then the remote sensors see over a broader portion of the spectrum than the human eye. So, that is advantage. So, when we are in an aircraft, we can see larger area, or if you say the satellite which is further above the aircraft, say this range. So, it will be getting much broader portion of the area which is it is taking, and that way maybe watershed or a river basin scale we can easily get the data required for the say various hydrological modeling or development of watershed management plans. It is possible. The sensors can focus in on a specific bandwidth in an image, as I already mentioned in the previous slides. So, they can also look at a number of bandwidths simultaneously. So, some of the satellites it can look into the area at a number of bandwidths simultaneously. So, that is the advantage. So, nowadays the modern satellites. So, the remote sensors often record signals electronically and provide georeferenced digital data. So, say the data which is say either through diffraction or reflection or whatever way it is getting back to the satellite. So, the data is obtained georeference, so that we can easily identify what is the location, and this data will be digital, and then that data we can process, and then we can develop appropriate maps or appropriate data requires for hydrologic modeling or the development plans. Some of the other advantages like remote sensors nowadays with the modern techniques we can have remote sensing or remote sensors operate in all seasons, at night and in all even bad weather. So, that way like microwave or the advanced types of satellites, remote sensing satellites can give the data all time at night or in any bad weather like heavy rainfall or cyclonic or whatever the weather conditions. So, in all these data can be obtained. So, that way this remote sensing technology has developed in the last few years, and we can see that now very sophisticated data, high resolution data, even up to 1 meter resolution, or even some of the satellites from USA or Russia, it can even go say higher resolution further to 1 meter, say like a 0.5 meter level. Things are available nowadays, depending upon say whether the usage, depending upon whether it is climate or the army or navy or whichever the agencies are using. So, accordingly various remote sensing satellites are available say by various agencies like NASA or Indian Space Research Organization. So, now since we are not going to cover in all the aspects of remote sensing, it is not possible. I am planning to give only one lecture dedicated to this remote sensing application as far as watershed management is concerned. So, that way we will be only going some of the important aspects which is relevant to the applications related to watershed management. So, now we have seen the basics. So, now let us see how the remote sensing is done and what are the important processes taking place. So, these details are given in this slide. So, the remote sensing process. So, actually to get the remote sensing data, there should be an energy source which is either reflected or diffracted like that, as I mentioned in the previous slide, and then this energy interaction with the atmosphere takes place, and then this after the interaction the satellite is getting back, so recording of energy by sensor, and then that data to be transmitted to the stations on the earth, and then that data to be processed. So, that way remote sensing process is quite complicated process. So, first the satellite should be there, remote sensing satellite should be there, and then that satellite is collecting the say sending certain signals, or say for example with respect to the heat from the solar say solar heat which is reflected, or that way also some satellites are there, or infrared region, whatever it is. So, this energy source, so first of all the remote sensing satellite passing over particular area, and then the energy source, and then energy interaction with the atmosphere, and then once that satellite has to get back this the data, and then that data is to be transmitted to the station, and then that data to be processed for further utilization. So, that way remote sensing process is a complicated process, number of steps are there, and then there are specified senders, remote sensing senders, say for example say in India it is National Remote Sensing Space Center NRSC located at Hyderabad. So, that way we say as far as watershed management plans are concerned, we are looking directly the data from the agency concerned for the specified date or for specified location by providing the latitude longitude for that particular location. So, that way only we request the data to the NRSC or specified agencies, and we collect the data, and then that data we have to process in say specified softwares like say ERDAS or other kinds of specified softwares. So, that process is called the image processing. So, image processing and analysis, so specific softwares are nowadays available. So, here what we are doing is we are doing the image restoration and correction, then we enhance the image. So, that is called image enhancement, then image transformation, and then we do image classification. So, this image classification can be either supervised classification. So, we can compare with the ground truth at few locations, that is called a supervised classification, or we can do unsupervised classification. So, these are the fundamental steps involved in image processing, starting from image restoration or correction. Once we get the image, then image enhancement, then image transformation, and then image classification, and then we can utilize this particular image for various applications. Say for example, this is say for a particular watershed, say the data is obtained, and then we get a FCC or parts color composition is done, and then based upon that we can get the surface features of that particular watershed, like the drainage pattern, or the river location, or the land use, land cover, like that. Nowadays various softwares are available, and that softwares like ERDAS can be used for this image processing and analysis. So, since our aim in this lecture is not to go into more details about the remote sensing, but we are mainly looking within the perspective of applications to watershed management. So, that way now let us look into what are the important advantages of remote sensing. So, here some of the few advantages I have listed here. So, here first one is we can have a synoptic view. So, like that when a satellite is passing that specified area wherever the scanning is taking place, that if that particular watershed is there. So, we get a total view of that particular area. So, we get a synoptic view, and then a temporal. So, that means when the satellite is again coming back after few days, say especially various plans for agriculture or the flooding problems. So, these kinds of temporal say variations we can easily obtain for that using the particular satellite data. So, that is the another advantage. And then of course, this remote sensing is multidisciplinary applications. So, various applications are there in hydrology, like land related applications, ocean related applications, climate prediction or weather predictions, or atmosphere related applications. So, number of applications are there which we will be discussing in the coming slide. So, now within the perspective of remote sensing data, so some few terms like spatial resolution, spectral resolution, temporal resolutions, and radiometric resolutions. So, these terms are important. So, let us look into the definitions of these terms. So, spatial resolution means a measure of smallest angular or linear separation between two objects that can be resolved by the sensor. So, that way we can consider the spatial resolution which we consider using the specific satellite which we use for remote sensing. And then spectral resolution means the number and dimension of specific wavelength intervals in the electromagnetic spectrum to which a sensor is sensitive. So, that is so called spectral resolution. And then temporal resolution means it refers to how often a sensor records imagery of a particular area. So, the area which we are covering, that particular area, say after few hours or few days or few weeks how we are getting the data. So, that is so called temporal resolution. And the last one is radiometric resolution, which shows the sensitivity of a detector to differences in signal strength. So, what is the signal strength which is getting back? So, accordingly the data resolution will be varying. So, that way when we deal with the remote sensing data, we have to see the spatial resolution, spectral resolution, temporal resolution and the radiometric resolution. Since we are now discussing only some preliminary aspects of remote sensing. So, anyway, let us look into what are the available satellites, some of the important satellites internationally available, and then also some of the satellites remote sensing satellites available in India. Let us have a brief look into this. So, here these data are given here. So, one of the major sets of satellites which we use for remote sensing is called the Landsat satellite. So, a series of satellites put into orbit around the earth to collect environmental data about the earth's surface are called as Landsat satellites. So, this is specifically for remote sensing. So, it can be for land related, ocean related or weather related satellites are there. So, various Landsat have had multispectral scanners MSS, then return beam videocon RBV scanners and thematic mapper scanners. So, this actually various countries like US and other countries came together, and that is the system of a series of satellites available for remote sensing. So, that series called Landsat satellites. So, each type has its own spectral range and spatial resolution as far as Landsat is concerned. So, three important methods of information extraction and interpretation using Landsat data is say like a photo interpretation, spectral analysis, data integration like that. So, Landsat is a series of satellites are very commonly used for remote sensing. And then say depending upon the purpose, whether we are looking to topography or the related to climate related parameter or vegetation. So, then accordingly also specific satellites are available. So, say if you are looking for topography, then the satellites called LIDAR, so which is airborne laser scanning based satellites. So, for say high resolution data we can use LIDAR data. So, highly accurate, say even up to the level of 1 meter. So, we can get 1 meter detail elevation models using this data, but the cost will be high, and special softwares and expertise needed to process such data. So, this is actually we can use say for example, say to get to the entire say for specified area how the topographic features changes even into up to 1 meter resolution. So, maybe say defense purpose, that kind of data can be used. And then another series so called shuttle radar topographic mission, so called SRTM related satellites and data. So, here 100 meter detail elevation model with almost global coverage. So, here under SRTM the which is say the data in provided by NASA in collaboration with other countries is called SRTM data, and it is available in the internet which is supplied by NASA, and here the interval is it is very coarse data of 100 meter resolution. So, this is actually free data. So, for say hydrological purpose or watershed management purpose, this data even we can utilize, but the resolution is very coarse, but still in many of the applications this SRTM data can be used. And another series of satellites called ERS 1/2 tandem interferometry. So, here it is somewhat higher resolution, 30 to 100 meter detail elevation model can be obtained from this. So, data from years 1995 to 98 available for most parts of the world. Accuracy vary depending on land cover and topography, and reasonable accuracy, say even less than 10 meter can be obtained for non-vegetated or flat terrain, and data cost moderate. So, here the cost is less and special software and expertise are needed to process this data from the ERS satellite data. Then another one, say related to vegetation, say if we are dealing with the land use, land cover and related data, we can further use the LIDAR airborne laser scanning. So, here actually this is a new series of satellite data which is having high resolution with say even up to 1 meter resolution we can have the data, and some of the satellites already are started to give data, and further say agencies like NASA and European Space Agency and Japanese space agencies, including Indian space agencies, are also now in the process of having further satellites in this LIDAR related satellites. They are putting and then getting the data. So, here full waveform satellites LIDARs for vegetation mapping have been proposed. So, the high quality data we can obtain even 1 meter resolution, but this data will be expensive, and for large areas it is difficult to get for larger watershed or larger river basins, but for small areas we can get the data and process. Then another satellite or series of satellite is SAR data. So, synthetic aperture radars or SAR system, SAR interferometry. So, here broad vegetation categories can be distinguished, and this is not suited for local scale, I mean less than 100 meter, and data cost moderate, specialized software and high level of expertise is required to process this data. So, that way various system is available to say for specified problems or specified say cases, we can get a specified satellite data and then process it and then utilize for that particular applications. So, now let us look into the Indian remote sensing satellites. So, here I have listed some of the important series of satellites put by Indian Space Research Organization ISRO. So, the beginning is in 1988 with Indian remote sensing satellite 1A, then 1B has been put in space, and that there the resolution was up to 72 or 36 meter with the 4 bands, and then 1994 IRS P2 has been put, and then IRS 1C in 1995, and then IRS P3 in 1996, then IRS 1D in 1997, which is even have a high resolution like a 5.8 meter, then IRS P4, then resource sat which is giving 23 meter resolution say in 2004. Then the latest development is so called Cartosat. So, where even some satellites, proposed satellites may give the resolution of 1 meter, and for larger applications related to either hydrology or watershed management or oceanic studies or atmospheric studies, this series of satellites can be used. So, this shows some of the important satellites available from India provided by Indian Space Research Organization. So, this is about the available satellites say internationally or say from India. So, now let us look into what are the important applications as far as remote sensing is concerned. So, as I mentioned earlier, so we here in this lecture we are mainly concentrating related to water related applications, so like surface water, groundwater, and then watershed related applications. So, mainly we are looking to the application sites. So, here in this slide remote sensing applications for surface water, the various applications have been listed here. As far as the remote sensing is concerned, for say pure water reflects radiation in the visible bands of the electromagnetic spectrum and absorbs almost all of it in the near and middle infrared bands. So, in the infrared water appears dark and is easily distinguishable from other land features. So, that way remote sensing data easily identifies the pure water bodies like lakes or rivers or the ponds to that level. And then the spectral response of water may vary with the presence of suspended sediments, which increase the amount of radiation reflected. So, if any sedimentation is there or the sediment problem is there, that also in a different way to be reflecting. Then surface runoff modeling of a watershed with land use from remote sensing we can use in hydrologic modeling, which we will be discussing in later lectures also. So, like we can obtain the land use land cover for the particular area, and then that from that we can obtain the reference coefficient like Manning's reference coefficient, that can be directly used in the watershed based modeling. Then a type of land use land cover significantly affects the runoff characteristics of a watershed. So, that way this data land use land cover for a watershed or a river basin we can directly utilize. The acquisition of land cover information is of significant value to water resource planners. So, that way we can utilize the remote sensing in an effective way for say watershed based or water resource based planning and management. Then in surface water resource development and management, remote sensing data provides catchment characterization, better modeling surface water resource like a rainfall to runoff. So, we need to identify for the given rainfall how much will be the runoff. So, that we can say either distributed models or say lumped models, we can utilize this remote sensing data in various ways, say for the hydraulic modeling to identify how much will be the runoff for the given rainfall condition. Then remote sensing data collects. So, whatever remote sensing data, whatever we collects multispectral, multi-resolution and multi-temporal data and turns them into information like land use land cover data sets. So, which we can directly utilize. And then as far as surface water applications concerned, we can identify the snow melt runoff. Say if a particular area, if snowfall, how much is the snowfall is taken place and how is the snow is melting. So, in a repeated way temporal variation we can obtain, and that gives a lot of information as far as snow melt, snowfall, snow melt and runoff is concerned. And then for surface water we can identify mapping of monitoring of surface water bodies. So, like if a reservoir is there, how much area is flooded, or if any flooding problem is there, say how the flooding is increasing or decreasing. Then we can also on river basin scale or for large areas we can assess how the water logging is taking place in that area. Then water temperature and other qualities of water we can identify, even water pollution or sedimentation or even say related to ocean oil spillage in ocean. So, all those things we can identify using the remote sensing techniques. Then detection of depth of shallow water and bed load also. Nowadays with modern remote sensing techniques we can obtain, say how much is the bed load taking place in a particular river, and then the depth of shallow water. And then another area is say a particular river, whether particular river or lake or a pond is polluted, that also with